Good morning, my dear students. Today, I want to discuss about that is three problems on current electricity chapter. That is mainly based on resistors. Resistor is the device or a component which is used to oppose the current in the circuit. That is a device or a circuit element which is used to oppose the current. Based on value of resistance, it opposes the current. Once you connect the resistor in the circuit, now the potential is dropped across that resistor, or you said to be resistance. What is the meaning of circuit? It is the interconnection between the circuit elements like resistor, capacitor, inductor and electrical energy source, that is called circuit. My dear students, I want to request to all of you, those who are view or watch our video clip, first you have to press the subscriber button, red button, and press the bell button. Then you become a subscriber for our channel. Okay. Yes, I hope all of you become subscriber for our channel. Yes. Thank you. Now continue. Resistance. Resistor resistance ಇರುತ್ತೆ. The resistance of the resistor. Usually that resistance is measured in ohm, and potential drop, potential or a cell, that is EMF of the cell. Cell means electrical energy source, which is drive the current or drive the charge in the circuit. Once charge is drive, definitely there is a current. That means the time rate of flow of charge across any cross section area of the conductor is called electrical current. Now potential drop. The potential drop is always measured in volt. Potential is measured in volt. EMF of the cell is measured in volt. But EMF is difference, potential difference. It is the opposition. It is a drop the potential. And but EMF is not like that. That is the electrical energy source. That is EMF is measured in volt. It is having internal resistance, but internal resistance is measured in ohm. Now, in a given cell, that is the opposition offered by inside the cell to the flow of electric current, that is called internal resistance. Internal resistance ಅಂತ ನಾವು ಹೇಳ್ತೇವೆ. Circuit they are resistor is connected across the EMF of the cell or the cell, then it becomes a circuit. ಅದಕ್ಕೆ ನಾವೇನು ಹೇಳ್ತೀವಿ, ಸರ್ಕ್ಯೂಟ್ ಅಂತ ಹೇಳ್ತೀವಿ. ಆ್ಯಂಡ್ ಆಮೇಲೆ ಕರೆಂಟ್ ಫ್ಲೋ ಆಗುತ್ತೆ, ಆಮೇಲೆ ಪೊಟೆನ್ಷಿಯಲ್ ಡ್ರಾಪ್ ಆಗುತ್ತೆ, ಇವೆಲ್ಲ ಕ್ಯಾಲ್ಕುಲೇಷನ್ ಮಾಡ್ತೀವಿ. ಇಟ್ ಇಸ್ ಮೇನ್ಲಿ ದೀಸ್ ತ್ರೀ ಪ್ರಾಬ್ಲಮ್ಸ್ ಬೇಸ್ಡ್ ಆನ್ ಸೀರೀಸ್ ಕಾಂಬಿನೇಷನ್ ಆ್ಯಂಡ್ ಪ್ಯಾರಲಲ್ ಕಾಂಬಿನೇಷನ್ ಆಫ್ ದ resistors. Before going to solving the problems, first you know about series combination and parallel combination. What is the meaning of series combination of resistors? Two or more resistors are connected end to end by applying the potential difference. This is called series combination of the resistors. And one of the very two important points in the series combination of the resistor, the first one is the current flow through each resistor is same. It is in the series combination. The current flow through each resistor is same, is equal to main current. But potential difference across the resistor is different. It is based on value of resistance. If more resistance, more potential drop. Less resistance, less potential drop. Like that. It is mainly depending upon what you say. That is resistance. According to Ohm's law, V is equal to I into R. So I is same, no. I is same. Then V proportional to R. I is same on that. V proportional to R. More resistance, more potential drop. This is in the series combination of the resistor. Now we come to the problem based on series combination. Now see here, there are three resistors, 2 ohm, 3 ohm and 4 ohm are combined or let's say connected in series. What is the total resistance of the combination? This is the first point I have to calculate this. And next, if the combination is connected to a battery of EMF 10 volt, 10 volt, it is a 2 ohm, 3 ohm, 4 ohm, okay, 10 volt, and negligible internal resistance, obtain the potential difference across each resistor. First you calculate potential drop across each resistor. First you have to draw the circuit here. Solution we have, that is the draw the circuit. What is that circuit? See here. Yes, fine. Okay. Now this is the series combination. This is the one resistor. This is another resistor. Another resistor. This is the series combination. And the combination connected to the EMF of voltage is there here. Internal resistance is 0 here. Now potential drop here V1, here V2, here V3. This is the resistance R1, resistance R2 and resistance R3. Equivalent circuit is, now this is the RS here and this one is said to be cell of the EMF and internal resistance. If the main current flow through, this one is I, it's the I. Current flow through each resistor is same in the case of series resistor. What are the things I have to calculate in this problem? That is the point. First you have to calculate total resistance, RS you have to calculate. If the combination is connected to a battery of EMF 10 volt, negligible internal resistance, obtain the potential difference across each resistor. It means you have to find out the very next point is I, then you have to find out V1, then you have to find out V2, then you have to find out V3 calculation mark. Okay, your I is a question mark, V1 is question mark, V2 is question mark, V3 is question mark. Yes, effective resistance, effective or equivalent resistance. Effective resistance, that is RS is equal to R1 plus R2 plus R3 I will take. Fine. Then RS is equal to 2 plus 3 plus 4. This is equal to 3 plus 4, 7. 7 plus 2, that is said to be 9 ohm. The value of series combination of resistance is what you say 9 ohm. Yes, fine. Now this is what? Okay, main current. That is the current. Current in circuit. Current in the circuit. I is equal to E divided by RS plus R. EMF, that is said to be 12. Now RS is 9 plus what you have to take here R 0. This is 12 by 9. Current is what you say here 12 divided by 9. You have to take here. That is combination. Okay. This is, I think it is 10 okay. 10 is the 10 by 9 ampere. Yes, main current is equal to 10 by 9. 10 by 9 ampere. Yes, potential drop across R1. Potential drop difference, a drop across R1. This is V1 is equal to I R1. This is equal to V1 is equal to I R1. I is 10 by 9. 10 by 9 into R1. R1 is 2 ohm. This you have to find out here. R1 is equal to R1 is how much? 2 ohm. R2 is 3 ohm. And R3 is 4 ohm. Yes, P1 is equal to, this is into, yes, Just 20 divided by 9. What is your answer? P1. P1 how much you got? You calculate it yourself. It becomes 1 point. That is P1 is equal to how much you got? 2.222 this. You got 2.2221. Yes, potential drop across, potential difference, a drop across R2. This is P2 is equal to I R2. I is 10 by 9. R2 is how much here? That is take your 3. This is 10 by 3. I think it is 1.111. 10 by 3. Yes, sorry. 3.33. 3 is the 9. Yes, 3.333. And potential drop across R3. P3 is equal to I into R3. 10 by 9 into R3. R3 is 4. This is 40 divided by 9. This is, I think it is 4.444 volt. This 4.444 volt. Now this is the cross verification. Make it into cross verification. How make it into cross verification? How much this is the V EMF is? EMF E is equal to, that is P is equal to 10 volt here. Yes. Now add these three values. 4 plus 3, 7. 7 plus 2, 9. 9 plus all the remaining you add, this it becomes 1. Again it becomes what? That is 10 volt. It means you have to calculate it. D is equal to P1 plus P2 plus P3. P is equal to 10 volt. We add these all the three values. Again you got approximately or exactly is equal to 10 volt, and your whatever you calculate the answer, that answer is correct one. You got the correct answer. This is the cross verification. Yes, you come to the next problem. Problem number 6 and problem number that is 7. It is based on parallel combination of the resistors. Parallel combination of the resistors. Yes, based on parallel combination of the resistors. And again, two more important points about the parallel combination. What is the meaning of parallel combination of the resistors? Parallel combination of the ಏನು? If the two or more resistors are connected across two common terminals by applying the potential difference, this is called parallel combination of resistors. Once again repeat, two or more resistors are connected across two common terminals by applying the potential difference is called parallel combination of resistors. Again, there are very two important points about the parallel combination of the resistors. What are the 2 points? One first point is here potential difference across each resistor is same. ಅಲ್ಲಿ current same ಇತ್ತು, ಇಲ್ಲಿ potential difference same ಇರುತ್ತೆ. Once again we repeat, first point is potential difference across each resistor is same. Then current flow through individual resistors is different. It is based on value of resistance. How? More resistance, less current. Less resistance, more current. Based on that one, the current flow through the individual resistors. Now, potential difference is same here. P is equal to I into R. I is equal to P divided by R. I is inversely proportional to the resistance. More resistance, less current. Less resistance, more current. Based on this point, wherever less resistance, more current is lost. But potential drop is reverse. Wherever more resistance, there is more potential drop. In In series or parallel combination, the very two important points. Okay, or the current, what is the behavior of the current, what is the behavior of the voltage or potential drop. This is. Now we come to the problem. Yes, what is that problem? Now see here, sixth problem. Yes, what is the sixth problem? Now see here, find. Yes, two resistors of resistance 12 ohm and 6 ohm are connected in parallel. Yes, this is R1, this is essentially R2, this is R1, this is essentially R2. Now are connected in parallel to a battery of 12 volt. Now internal resistance ಕೊಟ್ಟಿಲ್ಲ ಅಂದ್ರೆ ಅದು ಏನಂತ ತಿಳ್ಕೊಳ್ಳೋದು 12 volt E is equal to 12 volt. Internal resistance 0 ಅಂತ ತಿಳ್ಕೊಳ್ಳೋದು. Now main current is I. Now here current is I1, here current is I2. It's equivalent circuit. This is RP. This is RP. Now this is the EMF of the cell. V internal resistance. Current is essentially. What is R1 here? R1 is how much? 12 ohm. Yes, R2 is 6 ohm. Okay, calculate equivalent resistance of the network. RP you have to find out. Then obtain the current in 12 ohm and 6 ohm resistor. I you have to find out, right? And I1 you have to find out, and I2 you have to find out. R1 and R2 are the two resistors. They are connected in parallel across the battery of EMF 12 volt. It means internal resistance 0. Then it is the equivalent circuit. RP, what is RP? Equivalent resistance or effective resistance of parallel combination of two resistors. Yes, first you have to find out or parallel combination. 1 upon RP is equal to, or directly you have to write it. RP is equal to R1 into R2 divided by R1 plus R2. Okay. Then 12 into 6 divided by 12 plus 6. 72 divided by, that is basically 80. What is the answer you take here? That is RP. I think it is 4 ohm. What? 4 ohm. Your answer is 4 ohm. RP. Now current in the circuit. I is equal to E divided by RP plus. This is the expression for the current in the simple circuit. These are said to be simple circuits. Why? Because we analyze the circuit by applying only Ohm's law. What is meaning of analyze or analysis? You apply the Ohm's law. And you find out the current in the individual resistors and you calculate the potential drop across the resistor. This is result to be circuit analysis. What is the EMF? EMF is how much? Or voltage across this one. Now what is the RP? This is 4. This is 0. This is 12 divided by 4. What is what? 3 ampere. What is the answer? What? 3 ampere. Now this is V. V are essentially VP out. VP. Current in R1. I1 is equal to P is equal to IR. I is equal to V by R. PP by R1. PP by R1. What is VP? 12. What is R1? R1 is 12. What is the answer? 1. And similarly, calculate another current in R2. What is I2? I2 is PP by R2. PP by R2. 12 divided by what is R2? 6. 6 you got, this is 2. You observe this one, that is a cross verification. Cross verification, it means what is you got I1? I1 is 1 ampere. What is I2? I2 you take a 2 ampere. And sum of these two, how much you got the answer is here? Sum of these two, you got the answer 3 ampere only. 3 ampere only is nothing but what? This is the verification. Now total current you got 3 ampere and individually add these two values, again it becomes 3 ampere and your answer is correct. Okay. Now you come to the next problem, that is the seventh problem. It is seventh problem is also based on parallel combination of the resistors. Yes, I do this now. Parallel combination of resistors. Fine. So see here, you read this question. What is that question? Problem. Yes. 3 resistors 4 ohm, 6 ohm, 8 ohm are combined in parallel. What is the total resistance of the combination? If the combination is connected to a battery of EMF 25 volt and negligible internal resistance, determine the current through each resistor and total current drawn from the battery. This is the problem. Yes, 7th one. 3 resistors they are connected in parallel. 3 resistors they are connected in parallel. Fine. Its equivalent is RP. This is the R1. This is the R2. This is the R3. This is the E. Internal resistance is 0. Main current is I. Main current is I. EMF. Now current flow through R1 is I1. Current flow through R2 is I2. Current flow through R3 is I2. For our convenience, first you have to draw the circuit according to that the given problem or recently given numerical problem or question. Okay. Now whatever given value that you have to write. R1 is equal to, this is the R scale, June 2017. Before beginning problem is July 2014. Yes, 4 ohm. R1 is 4 ohm. R2 is, that is 6 ohm. R2 is 6 ohm. And R3 is 8 ohm. R3 is 8 ohm. Then what you have to find out? RP you have to find out. E is equal to Vp is equal to how much the voltage applied here? These are the resistors and this is 25 volt. What you have to find out? RP you have to find out. Voltage is given. Now I is you have to calculate and I1 you have to calculate and I2 you have to calculate. Then I3 you have to calculate. These values how to find out. First you have to find out RP. Yes, for parallel combination of resistors, for parallel combination of resistors, for parallel combination of resistors. And you write down. Yes. For parallel combination of resistors, 1 upon Rp is equal to 1 upon R1 plus 1 upon R2 plus 1 by Rp. Yes, 1 by Rp is equal to 1 by R1 plus 1 by R2 plus 1 by Rp. 1 divided by Rp. Therefore, 1 by Rp is equal to 1 divided by, what is R1? R1 is plus 1 by 6 plus 1 by 8. Now you got the LCM. LCM 24 is the LCM. 4 6 are 6 4s are 8 3s are. Now this is 13 divided by 20. Therefore, Rp is equal to 24 divided by 13 ohm is the answer. This is effective resistance of parallel combination of what are the resistors? 3 resistors. And what? That is 13 divided by, this is 1 divided by Rp. Then Rp is equal to what you got? 24 divided by 13. 24 is the resistance. This is the Rp. Then you have to find out, that is 1.846 you got the answer here. Rp is 1.846 ohm you got the answer. You calculate the current of, or to take here calculator. Then you find out the current, main current. What is the main current here? Main current. What do you got? Main current. Main current I is equal to, main current I is equal to E divided by Rp plus Rl. E how much E? E is, that is 25 divided by Rp is 24 divided by 13 plus 0 is a 25 into 13 divided by 24. What is the current it becomes here? I is equal to 325 divided by 24. This is 13.543. Correct. This is said to be main current. It means total current of the battery. Now current in each resistor. Current in, find out current in R1. I1 is equal to Pt divided by R. Yes, Pt is how much? 25. 25 divided by R1 is 4. What you got the answer? This is 6.25. You calculate with the help of the calculator. What you got the answer is 6.25. Then current in, that is R2. Current in R2, that is I2 is equal to Pt divided by R2, 25 divided by R2 is 6. This is equal to 4.167. And current in R3, I3 is equal to, now this is Vp, it is 25 divided by, I think it is 8. This is the 8 is equal to 3.125 M. Now this is I1, this is I2, this is I3, this is. Add these 3 values, cross multiplication. 6 plus 4, 10, 10 plus 3, 13 because 13 is remaining fraction of the. Add this value, it got 0.542. This is the answer for this problem or numerical problem. That is Rp. First you have to calculate Rp 24 ohm, 1.846. Then main current drawn from the cell in the whole circuit 13.542. And current flow through this resistor, it means 6.25 ampere. And I2 4.167 ampere. Then R3, I3 3.1. Now see here, observe this one. R1 is less than R2 is less than. Okay? R1 is less than R2 is less than R3. Highest test is R3, lowest test is 4. 8 is R1 is the lowest. 8 is 4. Our current observe made reverse is I1 is greater than I2 is equal than I3 because I is equal to resistance. It means current flow through allow the resistor that current depending upon the value of resistance. It means more resistance, less value of current. Less resistance, more current. ಹಾಗೆ ನಾವೇನು ಮಾಡ್ತೀವಿ ಅಂದರೆ ಕರೆಂಟ್ ಮತ್ತು ರೆಸಿಸ್ಟರ್ ದೇ ಆರ್ ಇನ್ವರ್ಸ್ಲಿ ಪ್ರಪೋರ್ಷನಲ್. ಇಟ್ ಮೀನ್ಸ್ more current, more resistance, less current, less resistance, more current. Like that, you have to find out this one. Yes, this is about series and parallel combination. Usually asked in the examination, these such type of problems you have to solve yourself. You got full mark. Now in each and every calculation final answer should be having their own unit. Must and should have to write the unit for the resistance is ohm, for the unit of current is ampere, like that. Okay, this is about series and parallel combination of the resistance problems. Now whatever you draw the circuit yourself, you read the question. Okay, you think it, how you to draw, what type of problem it is asked, how you draw, you think yourself, then you draw it. Then usually whatever asked in the problem, that you have to calculate. Now total resistance means effective resistance of the combination. This is about the series combination and parallel combination of the resistors. Thank you. One more request to the student: you become a subscriber for our channel. You press the red color subscriber button and you